In the last 2 weeks, I finally made use of pieces of code I was showcasing to you in previous videos. I started working on the sprite importer tool. It has some cool optimization, which I will show you later. Also, I extended my custom UI library with vertical scroll control, so let's dive in. In my previous game, Pumpkin Man, when I wanted to add another sprite, I had to manually edit this new sprite into one huge sprite atlas and then type in its coordinates into this single long file of all sprites' coordinates. It was quite painful, especially for sprite animations for which each frame had to be individually set. That's why for this game I want to integrate sprites importing directly into my custom engine. I've already started working on this integration, so let's look into what I have prepared. In the engine configuration, I specify which directory should be scanned for images. I can preview all images in this directory. There is no support for subdirectories yet. I can also change the size of the previewed images. At this point, I can note that all interfaces are still a work in progress, while I'm figuring out all the features this tool needs. As you can see, there is a refresh button at the top. Hitting this button will force the tool to go through the directory once again and detect all changes that happen. So, if I, for example, change the color of this car in the graphic editor, then save and hit refresh, all changes will be represented in Sprite Viewer. If any new image is added to the directory, it also will be shown in the viewer after refresh. It works the same if any file is removed. This still works smoothly even for a larger number of files. I used quite a simple solution to make sure that this is well optimized. In memory, there is a 2048 by 2048 blank texture created. I divide it into 256 by 256 slot, but to make visualization cleaner, let's assume that the texture is 512 by 512. When the game is first started, each file in the specified directory has a slot assigned. The image is loaded into memory and rendered into its slot. Each image is resized to fit into the slot while maintaining its aspect ratio. Thanks to this approach, there is no need to keep all the images in a directory inside memory, which can quickly be too resource intensive if there are many large images. When rendering viewer, scaled down version of each image is used from the previously created textures. This limits the number of textures used. This also works nicely with detecting new files and removed files. If a new file is discovered in the directory, then if there's any slot left, it's simply assigned to this file. If there are no more slots available, new texture is created and the pool of available slots grows. When the file is removed, its slot is simply returned to the pool of available slots. This prevents creating unnecessary textures if there are a lot of changes in the tracked directory. Change detection in the same file works by comparing the last modification time of the file in the directory and the currently displayed version of the file in the viewer. As each image has the same slot assigned during the whole runtime, it's possible to simply clear part of the texture that is occupied by the image in question and render it once again in the same place. There is a lot of work to be done still with this, but I think it should go a little faster from this point, once I have figured out the basics. From the last time I updated you about the progress, I also have fully finished the text editor. I added a new grid layout, which you can see in action in the viewer tool. I also have implemented a vertically scrolled container. It works by clipping one larger container inside a second smaller one. The larger container is moving by its content is being clipped. It is possible to scroll a container using a mouse wheel, which moves content by a fixed number of pixels, depending on the scroll direction. Another option is to simply click on the scroll background to move it instantly to the desired position. I always found it tricky to implement, so it helped me to visualize that the set of possible positions for the scrollbar starts from the half of the height of the scrollbar itself and lasts till half of the scrollbar height before the background ends. Then, when a click is detected, the mouse Y coordinate is converted into a value between 0 and 1 in this area. If the click happens above the intended area or below it, then the value is clamped into 0-1 range. Let's call this value R. The min and max position is calculated from the content itself. The minimum is always 0 and the maximum is the whole content height minus the height of the scrollable container. The R value is mapped into a specific value in the min-max range. The last scrolling option is by by grabbing the scroll bar itself and moving it around. Calculating the final content position works the same way as before, and the scroll bar position is calculated by storing its current mouse position in a given frame and then comparing it with the mouse position in the next frame. The difference is how much the scroll bar moved, the current mouse position is stored again, and logic repeats. That's all for today's video. I'm glad that finally I was able to implement some proper features which will end up in the final engine. From now on, hopefully, progress should be more focused and steady. Thank you all for watching, subscribe for more and leave a comment if you have any questions. And I'll be back in 2 weeks with more updates. Have a nice day.